9 regions here. So what are these 9 regions for? 9 regions are the top, bottom, left, right, top left, top right, bottom left and bottom right. And the other one is the center. So we're going to have the 9 regions, and these 9 regions will define whether the line is falling inside fully, or is the line falling outside fully, or is the line is partially inside or partially outside. All right, so this is about one case of the identifying about the regional codes. Right, so we have 9 regional codes. 9 regional codes, where all these 9 regional codes specify whether we have the line inside or outside. All right, processing time. Okay, what are the how do we define the region code? If you ask, if we take this as a regional code for the center, that means for the clipping plane, we have 4 particular values. What are those 4 particular values? Top, bottom, so we have the top, we have the bottom, we have the right, and we have the left. Right, so for the top term, the first term will be 1. The first term will be 1. I'll just deviate it so that you can understand. So we have 9 regions here. So for top, the first term will be 1, and for the bottom, the second term will be 1. The second term will be 1. What about for the right? For the right, the last second will be 1, means the last will be 0. So here also 1, it's not in the bottom, it's in the right, it's not in the left. So here it is again in the right, it is not in the left. So here on top left is 1 0 0 1, and only with respect to the top it is 1000, and only with respect to the left it is 0 0 0 1. So bottom left is 1 0 1 0 1, and only bottom will be 0 1 0 0. So this will be the so that this will be the regional codes for identifying whether the line is inside or outside. I'll just give a small hint here. I'll consider this line. Right, if this line is here to here, that means from this point to this point, from point P1 to P2, from P1 to P2, that means the line is completely inside. All right, if my P1 to P2, I mean P3 to P4, so they are completely outside. P3 to P4. Even for this also, in the clip test, we will be safe. Why? Because the line segment is completely outside. So when this case come in this way, right? So then this thing changes. So this is what? This is P4, and this point will be P5. So what do I understand from this now? I have a particular I have an intersection here now, right? So according to the algorithm, we'll deal with this, right? In order to understand the algorithm, we'll consider this program which we have. So what does the program say here? The program says that starting from the beginning, we have the main, and These lines have been commented by because you can get the values from the user, or you can create your own, or take the values from uh, the default values also. Okay, somewhere here in the display function we have taken that anyhow. Okay. Display, yeah, x naught, y naught, x1, y1. It's already there, but yeah, if you want, you can go with those points also. The next thing is collecting the basic values of command line arguments and count vectors. Is it a 2-dimension or a 3-dimension? So it's a 2-dimension, and one single buffer is more than enough. That means we don't have any of the any places where we have any translation, rotation, or scaling. So not basically it's a 2-dimension algorithm. So glut init window size. Window size is 500 pixels from 500 pixels, starting from 0 to 0. 0 to 0, and give that window name as Cohen Sutherland line clipping algorithm. Then you start with the display method. We'll go to the display method. So in the display method, we have uh, the values which needs to be taken to create. Okay, so basically I'll show you how exactly output looks, then we'll re-engineer. Right, so I have 500 by 500 pixels starting from 0 to 0 location. So this is my initial line. Okay, so we have two particular windows here. You should see that. Okay, so one window is for the line segments which are passing through. I'll show you how exactly this thing works. So for your understanding here, I'll be pushing it over here. Okay, so in the display we have x naught as 120, y naught as 110. I mean 10, x1 as 40, and y1 as 130. So we have two line segments, if you can see. Right, so two line segments. One is with 120, 120 and 10. Right, so the other one is 40 and 130. So here, x naught is 120, x1 is 40. Sorry, x naught and y naught is 120 and 10. Right, and x1 is 40 and y1 equal to 135. So we are clearing the color bit. That means we are taking a new color. Then what is, we have to select a color. The color which I'm selecting is the red one, red color. Yeah, so next is we begin with GL begin of GL lines. So here we are creating the value with the lines. So what are those? X naught and x1, x1 and y1, x naught, y naught, x1, y1. So we take it with these values, and we also take from 60, 20, 80 and 120. We create the line. So those red color value from here to here, x naught, y naught to x1, y1. And the other one is we also have another line segment. So 60, 20, 80, 120. So 60 to 20, maybe this will be the one. Yeah, 60 and 20, 60 and 20, and 80 to 120. This is the line for this. Okay, so what about the other one? X naught, and this is the other one, 120, 10 with 40, 130. I hope you people can see this. If you look into the cases here with the line values, 120, 10 is this. This is the point, 120, 10, and the other one is 40, 130. 40 is this, and 130 is this particular point. Example could be taken with only one also. We can work on single example also, but here I'm taking two examples. We'll look into separate examples, and we'll also look into it. We'll consider it. The other case is 60/20. So this will be your 60. Yeah, this will be your 60/20, and this will be your 80/120. The coordinate system which I'm actually telling you. You can change it. You can also give many more which are falling inside it and outside it also, and falling under any of the regions. The next one is, okay, once we write the diagram, I mean the line segment here, I should draw a clipping plane, right? So in order to draw the clipping plane, you see that I'm changing the color here. To what color? To the blue color. Then it's a line loop. So what is that line loop? We are taking x min, y min, x max, y min, x max, y max, x min, y max. Right? So what are these x min, y min, x max, and y max? X min, y min, x max, y max are the values for the window boundaries. So this window which we have on the bottom. So here x min is 50. X min is 50. Y min is also 50. X max is 100. Y max is also 100. Right? We'll come back here and let me help you out in understanding that. So x min and y min both are what I did. This is 50, right? So x max and y max both are 100. I want to draw this line, this particular blue line here. So I have to start with the vertex for the line loop, right? GL begin line loop, and I have to start with here. So what is that? I start with x min, y min, x min, y min. Then the line segment will go to x min, x max. Then from x max, y max, then x min, y max. And as it is in a loop, once you put the end, it will come back here. That's basically, you have drawn this and you have drawn the line segment. I hope you people follow it. And once it is done, once we have done with the blue or whatever the color here, red line segments with blue clipping plane. Once it is done, next we call the Cohen Sutherland line clip and draw. We do it for two values. You can see here, we do it for two values. Two values in the sense, these are two line segments. These are two line segments. 1 second, guys, I am getting a call. 1 second. Yeah, so we are taking two lines here, right? Why? Because we have opted for two line segments. There are two line segments which are passing over. Is it not? So if you look into the diagram here, there are two line segments which we have drawn. So how many line segments you have, so many times the algorithm has to be called. You might be wondering why we need to call it. That means we need to do the clip test. That's why we have the clip and draw here. All right. So first with x naught, y naught, 1, x1 and y1. So what are those values? X naught, y naught, x1, y1. So these are the values. So 120, 10, 40 and 130. So what will those be? This will be the one. 130, 20 and the other one which is here. All right. So Cohen Sutherland line clipping draw. We go for that method. Okay. So Cohen Sutherland line clip drop, we have taken the 4 values here. So first we need to check out the outcodes. Where exactly it is lying. Is it lying inside, outside, partially inside, partially outside, or the vertices are outside and the line is passing through the clipping window. So these are the things which we need to look into. For that, we need to set the codes where exactly they are. So we refer to right as 8, left as 2, top as 4, and bottom as 1. So these are the bytecode values. So, or you can also call as the outcode basically. Okay. So yeah, Cohen Sutherland algorithm, we come here. So outcode 0 is equals to compute the outcode x naught with y naught. Where exactly is x naught and y naught? So go to the function compute outcode x naught and y naught. Here it is, x naught and y naught. So outcode will be by default will be equal to 0, and if my y is greater than y max, y is greater than y max, so you come to a conclusion that code is with respect to the top. Else if y is less than x min, then this code will be equal to the bottom. That means from where it is lying. If x is greater than x max, then code will be starting from the right. Else if x is equal, else if x is lesser than x min, code will be equated with left. If none of these are matching, that means that my line is inside the clipping window itself. That's why we assign it with 0. By default, it will be inside. If my x and y values are anywhere on top, bottom, or left or right, then it will be in this case, right? If you can see here, y is greater than y max. That means y axis comes with top and bottom, right? So code will be top. If y is less than y min, then it will be in bottom. Similarly, x with x max, that means towards the x axis, that is right. And if x is less than x minimum, it is left. Very easy to understand. So here we computing the outcode. All right. So once the outcode is done, we'll actually come back to the same place so that we'll be knowing what exactly those outcodes are. So is it right, left, bottom, or top? For which all? For both the values, for x naught, y naught, and for x1, y1. That means for a particular line segment, we have two terms, right? Two terms in the sense x naught, y naught, x1 and y1. So we need to check whether both the vertices are in the same region or not. All right, so we got to know about this. If it is in the center, the values will be 0. If not, some other value will be there. If outcode or outcode 1, not outcode 0 or not outcode 1, that means accept will be equal to true, done will be equal to true. Why we do is logically we are checking for the acceptance or for the exit. All right, if I have 0 here, and even though here I have 0, that means not 0 is what? 1. If it is true, that's what. If it is true, then you have to accept, and done will be equal to true. Else if outcode 0 and outcode 1, that means both should be 1. I hope you people are following it. So if both are 1, again I don't need to do it, because no need to work out with the line segment which are outside, right? If my outcode is 1, outcode 0 is 1, that means x naught, y naught, my initial vertex is outside. And if the outcode 1 is also 0, if both are 0, that means we won't work with it, right? We ignore it, no need to work. So any of the codes, if any of the codes is high, or if any of the outcodes is 1. That means if it is 1, you remember that it is outside, right? So if in case both are 0, that means both starting and ending both are 0. That means my clipping window vertices are actually inside. Looking into this case, if here for this case, for this line segment which I have, both are actually outside, right? So if both are outside, it will show you that, yeah, both one is on the top and other one is on the bottom, but it will check, is it passing through any of the line segment? All right. So next, we have to check for the failed tests, right? So we check for, is the outcode equal outcode out is equals to outcode of 0, then you execute the outcode of 0 or you execute the outcode of 1. Before that, once we get to know whether it is outside or inside, the next term is we need to check whether it is in the top or bottom or in the right or in the left. Why? Because we also need to check if the line segment is passing through. Here, my both the vertices are basically outside. That means I cannot ignore it. Why? Because from top to bottom, somewhere it might be going through any of the clipping boxes also. So in order to check out that, we go for this condition. So if outcode out and top, I get both the values, x value will be equal to x0 plus x1 minus x0 into y max minus y0 divided by y1 minus y0. Similarly, for this is for the top, this value will be for the bottom, this will be for the right, and this will be for the left, right? So what I'm telling you, what we are checking here is my line segment. I'm looking here, is it intersecting anywhere? If it is intersecting anywhere, the x and y value will be set. And if those two values are set, it checks for the outcode out. Is it double equal to the outcode 0? Then it assigns what will be the intersected value. Basically, what these x and y, new x and y values which are doing is, they are calculating these intersection values, my new values of x and y. So it calculates that. So once it calculates that, it will be assigned to the new x0 and y0, and again it computes whether they are inside or outside. Once you come to a conclusion that, okay, we have found out the values of those, then we need to draw it, right? Then we need to calculate it, and we need to draw. Drawing in the sense, we are not drawing in the same image. We are drawing in a different image, which you can see in the center. Okay, so here this value, this point is xv minimum, yv minimum. This is xv minimum, xv maximum. So this is xv minimum, yv maximum. Oh, yv maximum. This is xv maximum, yv maximum. So those values have been put up over here. So what are those values? 200, 200, 300, 300. So this is 200, 200. This is 300, 300. This is 300, 200. This is 200, 300 value. So these are the xv min max, yv min max value. So after calculating those values, we need to draw this line from here to here. So we have to compute my Vx0 and Vy0 from where it is starting. Similarly, Vx1 and Vy1. And it depends on the scaling factor, because I'm scaling here, right? So Sx and Sy, we get the value and we multiply because we are in turn doing or some other clipping window here. You can call it as a clipped window. Not this will be the clipping window, and this is already clipped, and this is the clipped window. So you have to generate the values. Once you generate the values, you have to print it. So how do you print? We have to create a line segment, right? We have to create a line. Sorry, first we are creating a clipping box. with 4 values. You'll get to understand here with red, and we have to put it in the loop, right? So we create with this. So what is xv min, yv min? Xv min, yv min is 200, 200. So xv max, yv minimum is this point, 200, sorry, 300, 200. Next, xv max, yv max is this particular point. This is 300, 300. And from there, xv min, yv max, this is xv min, yv max, which is 300, sorry, 200, 300. And again, as it is in a loop, once it sees the end, it will come back here and it will create this particular clipped window. Okay, so once you create the clipped window, you want it. I want to consider these updated lines, that is Vx naught, Vy naught, and Vx1 and Vy1. So what we do, we call the GL begin of lines from Vx naught, Vy naught, and Vx1 to Vy1. So for the first line, basically this is the one, because we took this value first, and so this will be generated. This will not be ended here, because there is also, once it is done with Cohen's algorithm, it straight away comes back to display function. We also have another line segment, that is 60, 20, 80, 120. That is this line 60, 20 from here, and 80, 120. Again it will be sent. Again it will be sent. Again the outcode will be generated. Again we have to check whether is there any, the clip test basically, do we have any intersections with it or not. Then we'll calculate the new line segment values. We'll print it. We will print it. That's how the Cohen-Sutherland algorithm is basically working. So what I'll do is I'll create few more cases here. I'll draw this. I'll change the values, and I'll also show you with what are the values which it is currently working on. So for that, we'll go to the display statement here. So what I'll do is I'll take off this particular values. So initially we have 50 and 50, 100 and 100, right? So this line segment should not be passing through this 50, 50 to 100, 100. Okay, so what I'll do is 25, 25 and 25. From 25 to 25, I mean 25, 0, right? Yeah, x naught will be 25 and y naught will be 0. Okay. Not take it as 0, we'll take it as 25 itself. And what about the other value here? I'm not changing with the any value with the x values, but I'm changing with the y value. Let it be 130 or let it be 100. Let it be 130, no issue. Okay, so now my line will be here to here. If it is here to here, it will not be there. Check it out. I'm running it. You see this line here, right? My value, I'm starting from here to here. This is the line. This is outside. This is nowhere with respect to this clipping plane. So what happened here? In my output also, this line has been taken off, because nowhere, nothing happened. This has avoided everything, because outcodes of beginning and end is outside. That's a cue that okay, it is partially inside or partially outside. So straight away we check, is there any line segments? Is this line segment intersecting with any point of the clipping plane? It will check that. Okay, that's also not happening. So it neglects it. False and false condition here. Straight away it is neglected. So what about the other term here? What if I put it exactly inside? Exactly inside refers to, I'll say it as 55 and 55. 55 and 55. 75 to 75. 75 to 75. Okay. 70 or 75, as far as those are falling under 50, 50, 100, 100. So if I run this case here, the line will be completely inside. Okay, can you see this? It is inside. It is inside, but it is not touching any of the values of the clipping window. But still, it as the point, both the points are inside, we don't need to do the clip test. right? The minimum line or the line segments between the 2 points, where 2 points are actually falling inside the regional plane, or sorry, inside the zero regional code. Uh, that means that it doesn't have any intersection with any of the sides, so it is falling inside. So with this, I think we have understood how exactly a Sutherland algorithm works, and we have this wonderful program, which will be your lab program also, right? So your syllabus, which we have in the lab sessions, has this particular program, and you people can actually go through it. I hope you people have understood it,